Good morning, everyone. My name is Dr. Pavan Kumar V. I'm an associate professor in Computer Science Department, B.V. Raju Institute of Technology, Natsapur. And today I'm going to discuss a course, Design Analysis of an Algorithm. Under this, we are going to discuss a topic called Characteristics of an Algorithm. So, my topic has been divided into two parts. First, we'll discuss what is an algorithm. Then we will come with the characteristics of an algorithm. Now, first, what is an algorithm? So, an algorithm is a sequence of normally we are calling instructions, but those instructions should be unambiguous for solving the problems, and it also obtain a required output for a certain input, and it should be produce a basic output with a finite amount of time. That means any algorithm we are writing, it should take in a certain input and it should be producing a specific output, and it should be complete within a finite amount of time, finite number of instruction it has to complete. This is normally an algorithm what we call. And the instructions are sequence of instructions. It should be must be unambiguous, and there should not be any ambiguity in the instructions. Now coming to the characteristics. So why characteristics are required for an algorithm writing? Normally we know that algorithm is in a sequence of instructions. Do you need to follow the characteristics? Yes, it is. Now look at that. Normally algorithm means a simply writing in a sequence of instructions, but it will not sufficient for accomplishing our task. Why? Because it has to means it has necessary to follow some basic properties of any algorithm. Example, the basic properties are input, output, finiteness, definiteness, and effectiveness. I'm not telling these only the properties for an algorithm. These are the basic properties of an algorithm. Now we'll look into that one by one. What is the meaning of it and what is the purpose of it? The first one is input. Normally input is a certain data, the data which we are passing to an algorithm. And what we'll get it? If I'm passing in an input to the algorithm will process this and it will produce a certain output. Now the thing is, does it require every algorithm must pass an input? No, it is not necessary. It is depends on the type of what type of algorithm it is. Sometimes the algorithms are taking input also. Sometimes it may not be taking input. If it is taking, it may take more than one input also. Take an example. If I want to print a value, I want to print some message. So message printing does it require any input? No need. Example, hello world I want to print. Hello world or some message I want to print. Do I require any input? No need, because it is simply producing in a display message which does not require an input. Now take in one more example. If I want to do in a addition of two numbers, so a plus b I want to perform. So if I want to perform a plus b and that I need to store into a C, first I need to pass a value, then I want to pass a b value, then only that operation can be performed. So in that case, input is mandatory, and here input I'm passing the two inputs. That's what I'm telling you. Any algorithm, we are passing an input, we are passing a data, and that data will process and it will produce an output. And that input, it required or may not be required. If it is may not be required, example is a printing in a message. Required, it is may take one element or more than one element. Here is a simple example where we are doing an addition of two numbers, where we need to pass a value, we need to pass a b value, and whatever the addition we perform, that will be taken, that will be addition is going to store into the C. This is about the input. Now what about output? Does any algorithm has to produce an output? Yes, it is. Compulsory, an algorithm must produce an output. So it's not like an input we may take it or we may not be take it. It is okay, it'll up to the algorithm. But if it is an algorithm, it has to produce at least one output. So what is output? It is normally the output is a data result, from the computation. As I already told you, we are passing in a data to an input algorithm. It will process and it will generating a some result. That result we are calling an output. Now, if it is an output, does any algorithm having only one output? No, it is not necessary. It may have more than one output, but it has to produce at least one output. Take an example. Now, I want to do in the same, we will take in the same example. Now, I want to do an addition of two numbers. So, C equal to A plus B. A plus B I am performing. Now, how to pass in a input those A and B value? Now, A and B value, if I said values, so values means can I pass A value is 10? Yes, it is okay. A value is 20? Yes, it is okay, good. Then if I performing a addition operation and C value produce the 30 and 30 will be printed. I want to write in such algorithm. Now, in case if I'm passing A values, some called A, and B values, some is called C. That means instead of passing numbers, if I'm passing a characters, can I do addition operation? No, I cannot be do, because addition operation normally we perform in numbers and I'm passing in a characters. So in this case, what will the output? The output should be your algorithm must tell that you must pass in a integer number inputs, not in a other character, other number, other values like characters and some other values. That's what I told you in a second point. An algorithm should have one or more well-defined output, and it should match the desired output, and desired output also it should be matched. But it is a one or more output. Example is in this case it is producing the 30, and in this case it has to produce the given numbers are not a numbers. Given values are not a numbers. These are the output has to produce for the given input. Now, the third characteristic is finiteness. The algorithm must stop eventually. Now, example, I am writing an algorithm. Okay, as per the previous characteristics, it has to produce an input. It has to take an input. Yes, it will take it, and it has to produce an output. Yes, okay, it will generating. The thing is, I have taken an input and my algorithm continuously getting executing is not producing any output. Does we have any meaningful algorithm? No. Any algorithm, if I'm writing, it has to complete within a certain number of instructions. If the algorithm is getting executing infinite instructions and it is not producing any output, such algorithm there is no use of it, which is not producing an output. That means I'm violating the second characteristic. That means any algorithm, if it is taking an input or may not be taking input, the algorithm must execute a certain number of instructions. Normally we are calling a finite number of instructions, and it has to produce the output. That's what the algorithm must stop eventually. And stopping doesn't mean that you get the expected output. Okay, so stopping may mean that you get the expected output or you get the response to the no solution to the possible. That means it has to produce an output. It has to stop and it has to produce an output. The output is varying. Output may be your required output or may not be a required output. Means what are the input we are passing, it may not be suitable and it has to produce some message. Some like previous example we say that if I'm doing an addition of two numbers, if I'm instead of passing it values, that number values, if I'm passing a characters, in that case it has to produce some output. That is okay. Response that the values are not a number, it has a characters. That what? So it has to complete within a certain time. So that means there is no point to developing an algorithm which is a infinite as will be unless of for us. There is no point, there is no point to developing such algorithm which is going to be executing an infinite. That means not producing an output, and it is getting executing. Okay, so that was the property of the algorithm. There is a character, there is finiteness. Now coming to the next characteristic, definiteness. So what is the definiteness? An algorithm must specify every step and the order the steps must be taken in the process. And definite means to specify the sequence of operations for turning input into the output. Now, I am writing an algorithm. Okay, so as per the set, there is a sequence of instructions. I am writing the sequence of instructions. Now, every instruction there must be a meaningful. Meaningful means now I'm doing in a process called addition of two numbers. The steps I need to write in this way. There should be, I need to take an A input, I need to take a B input, then I need to take a plus B, then I need to store that into a C, then I need to print the C value. This is the following steps I need to follow. The thing is, every step having a meaning, and it is a processing towards to generating an output. And I should not write that, okay, taking a input and printing a B. Consider I want to print a B. There is no meaning in that. Clear? So that it should be every step must be a meaningful. So here is an example. You could not expect the computer to understand the something if you yourself are ambiguous about it. Now example, here it is. How my process is, I print A, I need to take an A input, I want to take a B input, I need to do processing. But instead of taking a input A, I'm printing the value here. I'm printing a value here. That will not be your system, your computer will not understand what you are doing. It's because it is an ambiguous step. Because I need to pass an A, I need to pass a B. But here, instead of passing in a B, I'm printing in a B. There is no meaning that. So that means every step must, there should be a meaningful, and we should not be in a stage that system will understand my instructions, because until unless we are writing in a proper meaningful instructions, system may not get that content. And the last characteristic is effectiveness. It means that all these steps that are required to get an output must be feasible with the available resources and should not contain any unnecessary redundant steps which could make your algorithm ineffectiveness. Simple example, now I am doing an operation called A plus 0 that I want to store into B. Now look at the statement, B equal to A plus 0. It's a 0. It is not a O, it is a 0. It is a 0. A plus 0. Now doing this operation, any meaning is there? Simply I am wasting the resource, that is a B resource, and there is one basic operation I am performing. Now there is a resource also wasting, and there is one extra instruction also I'm performing that. Extra instruction also I'm performing. So this makes my algorithm ineffectiveness. That means any instructions you are writing, okay, meaning wise it is correct. Definiteness, it is correct. What is that? I'm doing I'm taking in one variable, I'm taking one constant variable, I'm doing an addition operation, I'm storing into the B. Okay, that's good. But will it be effective? No, it is not effective, because our addition operation with the 0, the final result will not get it, because it is a same value. It is A plus 0 is A only. Doing an addition with a 0, there is no meaning that, because the value will not get changed, and the same value I'm copying into the B also. Clear? So this is about the effectiveness. So you take the simple example. Suppose you are cooking in a recipes, and you chop the vegetables which are not be used in the recipes until and unless recipes, then it is in a wastage of the time. Same thing it is. I want to cook. I want to cook in one vegetable. I want to cook in one recipe, and I prepared something like B has been prepared, but B I'm not using because there is no meaning in that A and B both are same. I have the same content is available in B also, same content is available in A also. Now which one I'll use it? I'll use it in only A. In that case, do I'm using a B? No. So simply the wastage of resources it is. The same thing is applicable into the normal cooking also. I cook. I want to prepare one recipe, but I prepared all vegetable or chop the vegetable, but I'm not using that. So this is effectiveness. So these are the some basic characteristics of an algorithm. So what we discussed today. So what is an algorithm and what are the basic characteristics of an algorithm? So characteristics are input, output, definiteness, finiteness, and effectiveness. Input means we are passing some data to the algorithm, and input may or may not be passing. And coming to the output, every algorithm must produce an output, and it may produce more than one output also. Definiteness is every step must be meaningful, and the finiteness is an algorithm that must be complete within a finite number of instructions. It should not be go infinite instructions. That means the stage processing and it is not generating an output. And last one is effectiveness. Every algorithm you have to write in a such statement which make your algorithm work in effective within a short time period. Within a short time period it will get executed. Unnecessary extra operations you don't write it. Like example here it is a plus 0. A plus 0 there is no need of doing an operation. So this is about the characteristics of an algorithm. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.